What would you do if you were to find the sum of the first 60 natural numbers from 1 to 60? What is the sum of all those numbers? Well, it's a little difficult to find out when we add manually all the numbers, isn't it? And how simple it would become if we had a formula to calculate that. But yes, it is your lucky day today, and it is really simple if you want to find the sum of the first 60 natural numbers. All you have to do is plug in the values into the formula and you will get the answer. But what is the formula? And that's what we are going to do in this video. So come on, let's nail it. So like I said, in this video we are going to find the sum of an arithmetic series. But what really is an arithmetic series? Well, you actually know what an arithmetic sequence is, isn't it? But when we want to find the sum of an arithmetic sequence or all the terms of an arithmetic sequence, it is called an arithmetic series. But what does an arithmetic sequence or an arithmetic progression look like? Well, we know that there's a first term in the arithmetic sequence which is generally denoted by the letter A, and then there's a common difference which is added to that first term to get the second term, which becomes A plus D because the common difference is denoted by the letter D, and then that common difference is again added to the second term to get the third term. So it becomes A plus D plus D, so it becomes A plus 2D, and then it goes on and on and on and goes up to the last term, which is also called the nth term of the arithmetic sequence and is generally denoted by the letter L. But where did this L come from? This is the last term which has been derived by adding the common difference to the second last term. So obviously the second last term is going to be the last term minus the common difference, which is L minus D, and similarly the third last term would be L minus 2D. Now if we were to find the sum of all these terms, which we could denote by the letter Sn, which stands for the sum of n terms of an arithmetic series, it could be written as A plus A plus D, which is the second term, plus A plus 2D, which is the third term, and it keeps going on until we come to the third last term, which is L minus 2D. Then add to that the second last term, which is L minus D, and the last term, which is L. Now we know that addition is commutative and the order of addition does not matter. For example, 2 plus 4 is the same as 4 plus 2, or 2 plus 4 plus 6 is the same as 6 plus 4 plus 2, or 2 plus 6 plus 4, or 2 plus 4 plus 6, or whatever order you take it, it is going to be commutative. It is going to give you the same answer. So obviously we can again write this S of n, or the sum of n terms of an arithmetic series, in the reverse order also. So we can write it as L plus L minus D plus L minus 2D, and it will keep going on till we come to the third term, which is A plus 2D, plus the second term, which is A plus D, plus the first term, which is A. Now if we were to add these two equations, what would we get? So obviously on the left hand side we will get 2 times the sum of n terms, so we can write it as 2 times Sn, and on the right side the first term A plus L, that will be the first term. Then we have got A plus D plus L minus D. Now obviously we see that the common difference is being added first and then subtracted, so that is going to cancel each other out, and what we'll be left with is again A plus L, and the third term, again the positive 2D and negative 2D are going to cancel each other out, and we'll again be left with A plus L, and same way we continue and till we come to the third last term, which again the negative 2D and positive 2D, they get cancelled, and we are again left with A plus L, and similarly we are left with A plus L here, and the last term again is going to be A plus L. Now you see we are getting A plus L every time, but how many times is it? Well, there were n terms in an arithmetic series, so obviously it's going to be n times, so we can say that 2 times the sum of n terms will be equal to n times A plus L. But what we were interested in was the sum of an arithmetic series, not 2 times the sum of the arithmetic series. So obviously if we divide both sides of the equation by 2, we'll get the sum of n terms of an arithmetic series as n over 2 times A plus L.
Hey guys, sorry for the interruption. I just wanted to interrupt you and tell you that if you're liking the video so far, it would really help me if you could just give a thumbs up to the video and do not forget to click on the subscribe button. Also, it will help me quite a lot. Thank you. Let's continue.
So let me get rid of all this and let me take this formula on top. Now we know that the last term of the arithmetic sequence, which can also be called the nth term of an arithmetic sequence, which can be written as an, has a formula for that, which is a, the first term, plus n minus 1 times d, the common difference. If we were to substitute this value of L back into the first equation, we can say that Sn, or the sum of n terms, is going to be n over 2 times a, the first term that we had, plus instead of this L, we are going to substitute the value a plus n minus 1 times d. And obviously, if we were to simplify this, we will get the formula again, which is S of n, or a sum of n terms of an arithmetic series, will be equal to n over 2, the number of terms divided by 2, times a plus a becomes 2a, plus n minus 1 times d. So that again is the formula for the sum of n terms of an arithmetic series. But does this formula work? Well, we'll have to test it out. So why not test it out right now? So let me take these formulas, put them on the right side here. Let me get rid of this and let's continue. So let me take any arithmetic sequence. Say let the first term be 3, then we can have the next term as 9, then 15, then 21, then obviously 27 and 33. So how many terms are there in this arithmetic sequence? Well, this is 1, 2, 3, 4, 5, 6. So there are 6 terms in this arithmetic sequence. So obviously the first term is a and the last term is a6, and the common difference is the difference between any two successive terms. So 9 minus 3 or 15 minus 9, it gives you 6. Now to test whether these formulas actually work or not, let us first find the sum manually and then we'll try to figure out if the formula works or not. So if we write the sum of n terms, or the sum of 6 terms in this case, we will get 3 plus 9 plus 15 plus 21 plus 27 plus 33, and when we add all of those, 3 plus 9 gives us 12, 12 plus 15 gives us 27, 27 plus 21 gives us 48, 48 plus 27 gives us 75, and 75 plus 33 gives us 108. So obviously the sum of these 6 terms is 108. Now what would we get if we were to use the formula to find the sum of n terms? So well, let's use the first formula first. So we have got the formula as Sn is equal to n over 2 times a plus L, and substituting the value, since there are 6 terms, so we can say that Sn is equal to 6 over 2 times a, which is the first term, which is 3, plus the last term, which is 33. So 6 over 2 gives us 3, and 3 plus 33 gives us 36. So 3 times 36, and that is equal to 108. So you see, we are getting the same result that we got in the first case. So obviously the first formula that we have here, that does work. What about the second formula? Does that work or not? Well, let's try that formula also to find out whether it really works or not. So obviously we've got the formula written on top, so we can write the sum of n terms, and let me substitute the value straight away. So because we are finding the sum of 6 terms, n is equal to 6, so we get 6 over 2 times 2a. So a has a value of 3, so we get 2 times 3 plus n minus 1. Now n is 6, so it becomes 6 minus 1 times d, the common difference, which is again 6. Simplifying it further, we get 6 over 2 as 3. 2 times 3 is 6, so it becomes 6 plus, and 5 times 6 is 30. So again we get 3 times 6 plus 30 gives us 36, and 3 times 36 is again 108. So you see, we are getting 108 again. So whatever formula we use, or if we calculate it manually, it is giving us the same result. So isn't it really very easy for you to use the formula and to find out what the result is? Now obviously you would be in a state of confusion, which formula should one generally use. Well, it really depends on the question. If the last term is given to you, you can use this formula. Or if you don't know what the last term is, but you want to find the sum of, say, 30 terms of an arithmetic sequence or the sum of 50 terms of an arithmetic sequence, you have the value of n, then you can use this formula. Now, there are a lot of questions which are there on the sum of n terms of an arithmetic sequence. And if you want to learn how to solve those questions, you should probably click on this video appearing here. You should also click on my photograph appearing here, because that is going to subscribe you to the channel so that you do not miss out on any future content. And do watch this video recommended by YouTube, which is going to help you a lot. And as far as the derivation of the formula for the sum of n terms of an arithmetic series is concerned, I think you have nailed it. Take care. God bless.